Okay, now let us start the chapter 4, which is the first chapter of physics. Uh, there are two types of motion: translational motion and rotational motion. Translational motion is also called linear motion. When a body moves in a straight path, such a motion is called translational motion. Rotational motion, when a body is pivoted, body has to be pivoted, and a force should be applied perpendicular to the body, then the body starts rotating about an axis passing through the pivoted point. Such a motion is called rotational motion. Probably these are simple things, they will not ask you that. We have uniform translational motion, the motion in which a body moves with a constant speed in a straight path. But in uniform translational motion, velocity will automatically be constant. Both will be constant. Speed and velocity both will be constant. Because in straight line path, the direction does not change. So velocity also will not change. That means when a body moves with when a body is in uniform translational motion, velocity is constant. So acceleration will be zero. Because acceleration formula, we have changing velocity upon the time. Since the velocity is not changing, that means the change in the velocity value is zero. So in uniform translational motion, the acceleration of the body is zero. And we say it is an example of non-accelerated motion, no acceleration. Whereas in a circular motion, direction every time keeps changing. So uniform circular motion time, speed remains constant, but the velocity will not be constant. Velocity will be variable, will be non-uniform due to change in the direction of its motion. So when the velocity changes, the acceleration will not be zero. So it will be an accelerated motion. That means non-zero acceleration motion, non-zero accelerated motion. Acceleration value will be there something. That is in uniform circular motion. Okay, now the first topic you have in syllabus is called moment of force. Moment of force, which is also called torque. Moment of force. We say the turning effect of force in a body about the axis of rotation passing through the pivot or passing through the pivoted point is called moment of force or the torque. It is measured by the product of the magnitude of force, which is the value of force, and the perpendicular distance of the line of action of force from the pivoted point or from the axis of rotation. So what I am going to say, suppose I am having a body, rigid body here, it is pivoted at this point, pivoted is clamped, hinged or tied at one point, and we are applying a force like this way we are applying a force F. This perpendicular distance from here till here, this is the point of application of force A. Here at this point we are applying the force, so you have to measure the perpendicular distance. That perpendicular distance we can denote by B or we can denote it by R. Therefore, moment of force we write MOF, that is moment of force or torque. Torque formula will be equal to F into D, force into this distance. The SI unit of torque will be Newton meter. SI unit will be Newton meter. And the CGS unit will be 9 centimeter. And how are they related to each other? We write 1 Newton meter is equal to 10 to the power sin 7 9 centimeter. It is same as last time I converted 1 joule into the earth, same method. Actually 1 joule is also 1 Newton into 1 meter, but that time the distance was in the direction of force. But this time the distance is perpendicular to the direction of force. Distance is perpendicular to the direction of force. So that is the difference. And this time turning effect is taking place, that we call moment of force. That's why SI unit of torque we don't say joule. Joule is especially used for work, and Newton meter is especially used for tau. Actually, meaning is same. One joule is same as 1 Newton meter, and here also is same Newton meter. But work is scalar and this is vector. That's why to differentiate from one another, there we use joule and here we use Newton meter. Okay, and here we have 9 centimeter. We don't call it erg. Okay, it is a vector quantity. It has direction. Whereas work is scalar. Work, power, energy, all of them are scalar. They don't have direction. The direction of moment of force or the torque can be clockwise and can be anti-clockwise. So it is a convention that the clockwise moment or the clockwise torque is taken as negative. We give a negative sign to the clockwise rotation, and anti-clockwise rotation or anti-clockwise moment is given a positive sign. So that's why the moment of force is vector, and the moment of force or the torque depends on two factors. It depends upon force and the distance. But the force must be acting perpendicular to the distance. That will cause the rotation. This time force is perpendicular to the distance. If we give a force, the body is pivoted here, but if we give the force like this, if we are giving the force in this manner, maybe like this way, line of action of the force here is along the line D, because this one and D is in the same direction. There is no perpendicular distance. So the D value will take 0 because the distance has to be perpendicular. If this is the force here, it is along the pivoted point, then the perpendicular distance is not available. There is no perpendicular. If it is over here, perpendicular distance is there. It is here, perpendicular. This is perpendicular distance like this. But if it is given like this line is coming along the line. Okay, there is no perpendicular distance. Then this D value will take 0 because D has to be a perpendicular distance. The only rotation will take place. I am tying this pen over here and I give a force here. There is a rotation. Surely rotation taking place. But if I give a force like this in this manner, there will be no rotation. Surely. If I do like this, there is no rotation. But if I do perpendicular, there is rotation. Either clockwise or anti-clockwise. The force has to be perpendicular to this distance. But if you give the force in the same direction as the distance, the torque will be 0. Understood? Okay, now next topic is couple. Couple means a pair. When we apply two equal and opposite forces, one force up, one force down, then the body starts rotating about the midpoint. Yeah, this is called pivoted point. We call fulcrum, but fulcrum now we are not using because the portion lever has been removed from the syllabus. So we are not calling it fulcrum now. We are just calling it pivoted point. So if there are two forces equal in value but opposite in direction are applied so that they are not acting at the same point. These two forces are not acting at the same point. Then what will they do? They will produce rotation in the body. There will be rotation, turning effect in the body. And such forces is called couple. The definition of couple we see a pair of equal and opposite forces producing rotation in the body is called couple. This force and this force both must be acting perpendicular to the body. Then we have the formula moment of a couple. Couple is pair of forces. Moment of a couple. Formula will be F, and this distance I will take the whole thing. I will take D. Force into the distance. This distance. Same formula. Force into the distance. Actually, why it is that is we will take one of the forces into the distance, perpendicular distance. We write as perpendicular distance between them, between the forces, between them. Perpendicular distance we take. This distance is from here to here. Why it is like this? Why we take only one of the force and the total distance? If you take both the forces, then this distance will be from here to here, the distance will be d by 2. This side also this will be d by 2. The moment about the point O will be coming f into d by 2, it will come like this, f into d by 2. Here also it will come f into d by 2, f into d by 2. take common here. FD is common, you get 1 by 2 plus odd 1 by 2 plus 1 by 2, right? FD over here. LCM is 2, 1 plus 1, 2 by 2, cancelling 1. So answer comes FD. So this is the reason why we write. This derivation will not come in exam, but this is the main logic why I have written like this. One of the forces into the perpendicular distance between them. So that will be the formula of the moment of a couple. So one important thing to be noted here. Moment of force or the turning effect or torque formula we have F into D. When this is constant, moment of force is constant, then force and distance they are inversely proportional. That means to produce same turning effect, if the force is more, the distance will be less. If the force is less, the distance will be more. They are inversely proportional. Or you can take it this way: shorter the distance, bigger the force; longer the distance, smaller the force. So they ask very often this question. Suppose we have a body and it is pivoted here. How can we turn it by giving the least amount of force? Least amount of force will give at the maximum distance from the pivoted point. Maximum distance is over here at this point. We have to give the force over here, maximum distance. When the distance is maximum, force will be minimum. With the minimum force we can produce turning effect in it. Okay. Okay, 1 minute. Okay, moment of force formula we have F into B. When the moment of force is constant, that is to produce same turning effect in a body, force and distance are inversely proportional. Less the distance, more the force; more the distance, less the force. Just opposite, reverse, or inversely proportional. So they ask quite many recent types question on it. Why the handle is always placed at the edge of a door? They will say to reduce the amount of effort needed to produce turning effect in the door. Since for a given torque, force and distance are inversely proportional. If you can write that also is better. For a given torque, force is inversely proportional to the distance. If you just mention that, this will be a better answer. Otherwise, if you say just to reduce the force or the amount of effort needed to produce turning effect in the door. There are many different types of questions are like this. They say why jack screw is provided with a long handle. Longer the handle, lesser the effort needed to produce turning effect in the jack. Because long screwdriver easier to turn a nut and all, it's easier. Screw to turn and all, so it is easier. Because longer the handle, with the lesser effort we can produce turning effect in it. So quite many recent test question we have. So when you want to turn a body about the midpoint, there we go for couple. Here is a pivoted point at the middle, exactly the midway. We are going for maximum distance on both the sides. This side also maximum distance, this side also maximum distance. What is the example of couple? Example of couple is steering wheel of a car. We are using both the hands, and the midway we have exactly in the middle we got the pivoted point, the axis of rotation. That is the rod. Supporting rod is exactly in the middle of it. So we are producing turning effect on it by applying the force, equal force in both the directions, like this. The back of a handle, the handle of a two-wheeler also is rotated with the help of a couple. So these are all quite many examples we have in our daily life. Okay. Like turning a tab, turning a key to a lock, turning a key, opening the bottle cap, we are using both the fingers and turning it. These are all examples of couple of the forces. Understood? Then we are into the next topic that is called equilibrium. Equilibrium. What is equilibrium? Equilibrium general meaning is the balance. If anything we are balancing like this, horizontal, we call it the bodies in equilibrium. That is balanced. But here the definition wise we see like this: when the state of rest or motion of a body does not change or remains the same, under the influence or under the action of number of forces acting on it, then the body is said to be in equilibrium. There are two types of equilibrium: static equilibrium and dynamic equilibrium. What is static equilibrium? When the state of rest of the body does not change under number of forces acting on it, then we say that the body is in static equilibrium. For unpivoted body, when the total forces acting on the body is zero, then the body will be in equilibrium, static equilibrium. The body will not move. That is, the total force acting on the body, if it is zero, then the body will be in translational equilibrium. Translational means straight line motion will not take place. When the total force acting on the body is zero. That means when suppose two forces we are giving, the two forces must be equal in value and must be opposite in direction on the body to keep it at rest or to keep it in equilibrium. What are the examples of static equilibrium? We say a beam balance in horizontal position, but that will be rotational equilibrium. There is no rotation taking place because pivoted body is exactly midway there, the beam balance. That means the beam balance remains in static equilibrium when it is in the horizontal position. Same way, a book on the table, so the weight of the book is acting downward and the table is giving a reaction in the upward direction. The two forces cancel out each other, the net force on the book becomes zero. That's why the book remains at rest. This is the example of static equilibrium. We got quite many examples like in the tug of war, two teams are applying equal forces on the rope. Then what will happen? Both the teams will keep the rope horizontal. The rope will be going neither of the sides. Will be tilting to neither of the sides. That means the rope will be in the static equilibrium. So these are the situations. Okay. Then another one is dynamic equilibrium, where the state of motion of a body does not change under the influence of or under the action of several forces or number of forces acting on it. Then the body is said to be in dynamic equilibrium. What are the examples? Raindrops. So many forces acting on the raindrops falling near the ground will be in dynamic equilibrium. Its motion will continue in spite of several forces acting on it. We say that the raindrops are in dynamic equilibrium. Planets are continuously revolving around the sun. It's also in dynamic equilibrium. Satellites revolving around the planet also in dynamic equilibrium. We have electrons revolving around the nucleus of an atom is also in dynamic equilibrium. So many examples we have where the motion is unaffected. Although the number of forces or several forces acting on the body, yet the body is in motion. Its motion is not affected. So now next topic is conditions for equilibrium. So there are two conditions for equilibrium. We say the total forces acting on the body must be zero. Then the body will be in translational equilibrium. And to keep it in rotational equilibrium, when the body is pivoted, the total clockwise moment must be equal to the total anti-clockwise moment about the pivoted point. Then the body will be in rotational equilibrium. If they ask give conditions of equilibrium, we will give both. If they ask give the condition for translational equilibrium, we will give the first one. Give the condition for rotational equilibrium, we will give the second one. That is the total amount of total clockwise moment is equal to the total anti-clockwise moment. That means the resultant moment of all the forces about the pivoted point must be zero. Then total turning effect is zero. Then the body will be in equilibrium. Now the next topic is principle of moments. Principle of moments. This one indirectly I already told you. It states that the resultant moment of all the forces about the pivoted point is zero when the body is in equilibrium. This is called principal moment. In other words, it says that the clockwise moment is equal to the total anti-clockwise moment. For this we have one experiment also. They show a meter rule like this, and it is suspended exactly in the midway, the midpoint, that is 50 centimeter mark. Maybe one weight we are hanging here like this, one weight with the help of spring balance we are hanging a weight here, another weight we are hanging with the help of spring balance here like this. This is weight W1, this is weight W2, then this is given. Then this one, the rod or the meter rule scale is horizontal, balancing horizontally. Then they may ask a question, which of the weight is bigger, W1 is bigger or W2 is bigger? What is your answer? W1 is bigger or W2? Which one is bigger? Why? W2 is closer to the 50 cm, closer to the pivoted point, closer. So when the distance is less, the force will be more. Since the distance is less, that's why this W2 will be more than W1. And here the distance is more from the pivoted point, that's why it will be smaller. We say W2 is bigger than W1. If they ask name the principle of the law used in this diagram, then we say principle of moments. Now if they ask to name one instrument or device in which this principle is used, then we say B balance. B balance. Alright. Okay. Now the next topic we have center of gravity. Center of gravity. What is center of gravity? It is the point at which the entire weight of a body is supposed to act. The weight of the body will be acting at a point, and that point is called center of gravity. Yes. Now the center of gravity, it is how to find this. One easy method is like this. We will be keeping the body rotational equilibrium due to its own weight. Without using any extra weight, we will try to balance it. Like for example, for this pen, I want to find the center of gravity. I try to balance it on my finger like this. So this point here, about which the body itself is balancing, becoming horizontal, that point is only called center of gravity. It will be somewhere in the midway, somewhere in the middle of the body. It will be, but not necessarily always. So center of gravity is the point about which a body remains in rotational equilibrium due to its own weight. That is the alternative definition of center of gravity. Question is, a body freely is suspended or freely pivoted, balances horizontally about a point. Assign a special name to that point. We say center of gravity. A special name will be center of gravity. Okay, now the center of gravity depends upon the mass distribution in the body, how the masses are distributed in the body. If the masses are uniformly distributed, it will be somewhere in the center or somewhere in the midpoint. If the masses are uniformly distributed. Now, when we change the shape of a body or when we deform a body, will position of CG change? Answer is yes, it will change. Because by changing the shape of the body, we are changing its mass distribution. And due to changing the mass distribution, its CG will change. Position of CG will change. For example, we have a wire out here, center of gravity will be exactly midway, but the same wire is turned into a circle like this. The position of center of gravity will be now here, outside. So it will change, position will change. Usually it will be closer to the center of gravity with the weight part, where the weight is acting. It will be closer to the heavier side, whichever side is masses are more. That side it will be closer. If the masses are non-uniformly distributed, unevenly distributed, that time. Suppose we are having two blocks like this. One is iron block, one is wooden block of same size, wooden block, same size. So question may come, where is the CG of this combined block or composite block situated? In between, exactly in between or within the iron or within the wood? What is the answer? Where will be CG situated? Within the wood or within the iron or in between, exactly in between? Where it will be situated? Tell me. Within iron, because iron will have more masses. Closer to the heavier side it will be situated. It will be within the iron, anywhere within the iron, not within the wood. Because iron is denser, it contains more masses for a given volume, for occupying the given space. Mass will be more. Then it is denser, so it will be within the iron. Now, is it necessary that the CG, position of CG of a body to lie always within the body, or within the material of the body? Answer is no. It is not necessary. It may even lie outside the material of the body. What are the examples? Like we got ring. Ring in the fingers. Ring is like this. Center of gravity is situated here, outside. Outside the material of the body. We have a hollow sphere like football and all, it will be situated outside the material. We have circular wire where it is situated at the center of the circle outside the material. Hollow cylinder, any kind of hollow body, it will be situated outside the material of the body. It is not necessary to lie always within the body. Okay. Yes. Okay, the next one is position of CG of the sum of the regular objects. So there is a table even in the book given, and you are supposed to know. Like in the notes also you will see. Have I sent the note? Okay, I will send it. I'll send today. Okay, then you see that. There is a table given. So in the table we have regular objects and other side position of CG. For example, first one is rod. If we have a rod, where is the CG situated at the midpoint of the rod? If the object is ring, where it is situated at the center of the ring. If the object is in the form of circular disc, where it is situated at the center of the disc. If the object is in the form of sphere, solid or hollow, it is situated at the center of the sphere. But if the object is in the form of a cylinder will be like this. So here it is slightly different. They may ask you about one of them. In cylinder, either hollow or solid cylinder, it is situated on the midpoint of the axis of the cylinder, somewhere here. In case of a cone like this. In case of a cone, this is called vertical height. This is called slanting height. So we know that this side mass is less because this is pointed, this is less mass, this side is wider, having more mass, it will be situated closer to the heavier side. So in case of a cone, solid cone, it is situated at a height h by 4. The total height, if you are assuming 1 part, 2, 3 and 4 equal parts, somewhere here it is situated. CG will be situated here at a height h by 4. At a height h by 4 from the base side, not from the top. At a height h by 4 from the base. And if the cone is a hollow cone, it will be slightly above, it's h by 3 height. At a vertical height h by 3 from the base side, there it will be situated. If the body is in the form of a triangular lamina, like this. Lamina means thin sheet of paper. Thin sheet of is called lamina. Yeah, lamination, you put a thin plastic paper over here on top of it. That is lamination, same thing over here. So, if you are having a triangular lamina, where it is situated, it will be situated at the centroid of the triangle. Centroid means where 3 medians meet. One median, another median bisects the opposite sides. Median will be bisecting the opposite sides here. This point, and this point will be all the midpoint of these sides. This point is called center of gravity. Where the 3 medians meet, we say point of intersection of the medians or the centroid of the triangle. We have done in maths also this thing. Centroid formula was what? x1 plus x2 plus x3 by 3. And y value was y1 plus y2 plus y3 by 3. So that is the formula. Now, if you have a body in the form of square lamina or rectangular lamina like this, where it is situated at the point of intersection of its diagonals, where the two diagonals meet, there it will be situated. So if we are having a meter rule, suppose meter rule, and the weight of the meter rule is, say I guess 100 gram force, 100 GF, where will that be situated? That will be situated because it is like rectangle. So I will be joining these two corners here like this. One corner, another corner I will join like this. It will be situated here, and this will be 50 centimeter from, because midway of rectangular, this will be midway, that is 50 centimeter. Here it is situated 50 50 centimeter mark. It will be situated maybe 100 grams or 100 gram force is acting there at this point. Here the weight of the entire cell will be acting at this point. At the point 50 centimeter mark. In case of uniform meter rule, the meter rule is uniform everywhere, same masses are there on both sides. So it will be like this. Understood? So this is about the position of CG. CG is done. Okay, now the next part is to do today or to do tomorrow. What is it? Okay, the next topic is theory part. I will finish today. Tomorrow we will do problems in the chapter syllabus is over. UCM, uniform circular motion. UCM full form is uniform circular motion. So, what is a circular motion? Uniform circular motion. We say that when a body moves in a circular path with a constant speed, then such a motion is called uniform circular motion. Motion of a body with constant speed in a around a circular path or in a circular path is called uniform circular motion, and we call it UCM. In short, uniform circular motion. What are the examples of UCM? Planets revolving around the sun, electrons revolving around the nucleus with the same speed everywhere. The speed is same. A piece of stone tied to a string and whirling in a horizontal circle like this. They all are the examples of uniform circular motion. Now, in a uniform circular motion, speed will be constant, but not the velocity. You can understand this way. What is speed is value same everywhere. Maybe 20 km per hour, it remains same everywhere. Value does not change, but the direction surely will change. Direction will change. At every point, the direction keeps on changing because the path or the track is a curved track like this, round. It is not a straight line. So the direction of velocity every time keeps on changing. The direction is changing, so velocity is changing because velocity is vector. What is the direction of velocity at any point of this motion? Direction of velocity is given by the tangent drawn at that point. I mark the points suppose A, B, C, D, and assuming that the body is moving like this. Anti-clockwise or clockwise, any direction you can assume. The direction of velocity is given by the tangent drawn at that point. Tangent drawn at that point in the direction of motion. Like this motion, here we draw the tangent. Here it is to draw the tangent here, velocity. Here the tangent is like this. Here the tangent will be like this. Velocity value will be the same. Everywhere the velocity value is v, but the direction is not same. Direction keeps on changing every time. The directions are different. So, in uniform circular motion, speed remains constant, but not the velocity. Velocity is variable or non-uniform. We can use the word. Why? Because of the change in the direction. Since if the velocity changes, then of course there will be an acceleration. And the acceleration will not be zero. In what direction the acceleration acts? Acceleration acts in the direction of force, and the force will be acting towards the center of the circle here. So that means the direction of acceleration will show like this. Direction of acceleration will show like this. Direction of acceleration will be acting like this way. This is the direction of acceleration towards the center of the circular part. Or we say along the radius. The acceleration is radial or is acting towards the acceleration is acting towards the center of the circular path. Towards the center of the circular path, the acceleration will be directed. Direction of velocity is given by the tangent, where the direction of acceleration is towards the center along the radius line, along the radial line or the radius line. That means angle between acceleration and velocity will be 90 degree, or we can say the angle between force. In this direction only the force will act. Force direction will also be the same. Force direction will be also the same. Force and acceleration will have same direction. The force and velocity, the angle between them will be 90 degree. In linear motion, in translational motion, force and velocity are in the same direction. But here the force and velocity are perpendicular to one another. So question may come. In which kind of motion force and velocity are perpendicular to each other? We say circular motion. And any circular motion you can say, but it has to be uniform circular motion or non-uniform circular motion, but force will be perpendicular to the velocity. Understood? That means is acceleration uniform or non-uniform in this case? Acceleration. Is acceleration uniform or non-uniform? What is the answer? No. Direction of acceleration is not changing. Check out here. Direction acceleration is vector quantities. Direction is changing. All the vector quantities. Direction of velocity is changing. Direction of acceleration also changing. Here also changing. Here also changing. Everywhere it is changing. Value does not change, but the direction changes, and due to changing the direction, acceleration as a whole changes. Because you can see over here, this is in the left side, this is right side, this is downward, this is up. Everywhere it is changing. The point is here, body comes here, the direction will be like this. Out here, the direction will come in, the direction will come in towards the center all the time. So, only speed remains constant in uniform circular motion. UCM full form is uniform circular motion, only speed remains constant, whereas everything else are variable, everything else are non-uniform. What is everything else? Velocity, acceleration, force, they all are non-uniform because they all are vectors. They all depend on direction. Directions are continuously changing, so that's why they are also changing. So they are variable. Understood? They are not uniform. They are changing every time. Now the next topic is centripetal force. We see when a body is moving in a circular path, the force is acting on the body where towards the center. Such a force which acts on a body towards the center of the circular path is called centripetal force. Centripetal force. Centripetal force. Centripetal is the combination of two words. Centri means center. No. Centri means center and petal means towards. The force acting on the body towards the center of the circular path, that force is called centripetal force, towards one. Okay, what are the examples of centripetal force? Centripetal force will be acting towards the center. When planets are revolving around the sun, what provides a centripetal force, or centripetal force is given by which force? We say force of gravitation. Force of gravitation, the sun is pulling the planet towards itself, that is towards the center. That force is centripetal force. We say centripetal force that time is provided by gravitational force. They may ask you about one of them. What provides a centripetal force in the following cases? Or they say for planets revolving around the sun, we say force of gravitation. For electrons revolving around the nucleus, electrostatic force between the proton and the electron. For a piece of stone tied to one end of the string and whirling in a horizontal circle, what provides a centripetal force? We say tension in the string. That means tension will be equal to the centripetal force in that situation. And when a body is when a vehicle is taking a turn on a curved track, on a curved road, what provides the centripetal force? We say friction between the road and the tire provides the necessary centripetal force. Understood? Okay, now we can see our body is over here and is moving in a circle all the time. Force is acting there towards the center. This is centripetal force. Yet we see the body continues to move in a circle. It is not coming towards O. Is it coming towards O? Is planet coming towards the sun and banging with it? Answer is no. Planets are continuously at that distance only revolving around. So what keeps the planet in dynamic equilibrium, or what keeps the body in a dynamic equilibrium? There we have to assume. We have to assume an imaginary force. This is called pseudo force, which must be balancing this force, and that force must be equal in value but opposite in direction, like this. This force is towards the center, that this force must act away from the center. This force is called centrifugal. This is an imaginary force or fictitious force which is assumed to be balancing the centripetal force to keep the body in equilibrium, to keep the body in the orbit itself, not to be moving towards the center, to keep it there at rest, over in the orbit. Otherwise, the body will be coming towards the center, will be attracted by the center. So the force which keeps it in equilibrium or by balancing the centripetal force is called centrifugal force. Centrifugal force is acting away from the center, from here is acting away from the center of the circular path. The force towards is called centripetal, force away is called from the center is called centrifugal. Fugal is acting away from the center. This is towards the center. That is the difference. Centrifugal force, centripetal force, they have same magnitude, same value, but they are in opposite direction. Direction wise, they are opposite. So many people they think that centrifugal force and the centripetal force. Centrifugal force is the reaction of the centripetal force. Like action and reactions are also equal and opposite. Every Newton's third law says every action is equal and opposite reaction. Is centrifugal force a reaction of the centripetal force? Question mark. We say no. Because action and reaction acts between two different bodies simultaneously. Whereas centrifugal force acts, centrifugal force and the centripetal force is acting on the same body to keep it in equilibrium. So centrifugal force is not the reaction of centripetal force. Because action reactions are always on two different bodies. One body will be applying the force called action, another body will give the force back, equal force back, that is called reaction between the two different bodies. We hit the wall hits me back. So action is my hitting on the wall and wall is hitting me back, that is the reaction between two different bodies, my hand and the wall, always two different bodies. But here centrifugal force, centripetal force acting on the same body. That's why centrifugal force is a fictitious force, is an imaginary force, is a pseudo force, is a non-real force, okay, which is assumed only just to describe the or explain the equilibrium of the body. Hope it is clear. Now centrifugal force is put into use in a machine called centrifuge. Centrifuge is mainly a device on which the liquid is rotated to separate the lighter particles from the denser particles of the liquid. Which lighter particles will be pushed out by the centrifugal force and they will be collected in the orbit that is at the center or there. Sorry, at the circumference. Like churning of milk is done by using the device called centrifuge. Churning is the process of separating cream from the milk. So boiled milk is put on a disc, or a disc is rotated with high speed. So all the cream particles which are lighter are pushed out, and we call it churning, and that is pushed out due to centrifugal force push them out. So that is the idea here. So centrifugal force and the centripetal force are equal in value, opposite in direction, but the centrifugal force is not the reaction force. Okay, understood? Yes, and at last you will find the, I think already told you that UCM and UTM. UCM is uniform circular motion and UTM is uniform translational motion. What are the differences, point of differences? In uniform translational motion, both speed and velocity are constant. But here, speed is constant but velocity is variable. Uniform translational motion, acceleration is zero, or we call it non-accelerated motion, no acceleration motion. And this one is having acceleration because of the change in velocity. So it is an accelerated motion. In the uniform translational motion, force and velocity are in the same direction, but here force and velocity are perpendicular to one another. They are perpendicular to each other. Force is perpendicular to velocity, not in the same direction. And examples we can suggest: uniform translational motion example will be a car moving with the same speed on a highway or on a straight road. So that is the example of uniform translational motion. And what an example of uniform circular motion? I gave many examples: planets revolving around the sun, electrons revolving around the nucleus. These are the point of differences. So this chapter's theory part is done.